can imagine it, technology can create it. It entertains, heals, connects, and protects. It greets us in the morning and guides us home at night. It can make our dreams a reality and can make reality feel like our wildest dreams. Technology completely changes how we see the world, each other, and the future. With tech by our side, we have the potential to solve the world's greatest challenges. Food security, access to healthcare, sustainability, and environmental impact. The more critical the issues, the more critical the need for problem-solving tech, especially as part of our pursuit of human security for all. So, as we move forward together, we do so surrounded by the world's greatest technological advancements all in one place. More than ever, CES 2024 is the celebration of all that tech has to offer humanity. There's positive energy in the air. We move forward with both hope and confidence because we're creating solutions in a global effort to make the world a better place. We're all on for powerful connections, joyful experiences, new opportunities, and everything that tech makes possible. Right here, right now. We're all together. We're all in and all on.
Please welcome our session panelists to the stage.
Hello and welcome. My name is Edward Wilford and I'm the Senior Principal Analyst for Applied Intelligence at Omdia, and I'm today's moderator for our panel on cracking the smart car, what truly defines them. Now, no industry has undergone transformation quite like automotive, and the process is still ongoing and by many measures early. A few figures to sort of look at on how the smart car is genuinely advancing on all fronts. First, Edge AI. Omdia forecasts a 20% annual growth rate from 2022 through 2028. Almost 1 billion Edge AI devices shipping into automotive at that final year. Connectivity. Ward's Intelligence suggests the total number of connected cars on the road worldwide is going to grow 5 times through 2034. That's 400% growth over that period. Software-defined vehicles. In an industry survey, 72% of respondents suggest that 50% of cars sold by 2033 will be software-defined. That's in a decade. Astonishing figures in an astonishing industry. So I'd like to dive right in. I'd like to first introduce our panelists. I'd like them to introduce themselves, please, starting with Danny.
Hi, I'm Danny Shapiro, Vice President of Automotive at NVIDIA.
Hi, I am Maite Bezerra, Principal Analyst for Ward's Intelligence, focusing on software-defined vehicles.
Hi, I'm Rob Botticher, Director of Technology for Automotive Manufacturing Vertical for Amazon Web Services.
Hello, I'm Maria Anhalt, CEO of Elektrobit.
Hello, my name is Remco Timmer. I'm Vice President of Product Management for HERE Technologies.
Thank you all for being with us today. The big question first, what makes a smart car smart? Is it the connectivity? Is it advanced compute? Is it software? Is it access to data? Maria, your perspective on this.
Yeah, smart for me is the ability to think, to learn, to do things that are done in a repetitive way by a human being, so she or he can enjoy the experience in the car, in the vehicle, and do something different. And of course, that kind of smartest is associated with artificial intelligence. But beyond artificial intelligence, we also have the connectivity within the vehicle, vehicle to vehicle and vehicle to environment, and how do we integrate the entire digital ecosystem into the overall experience. So if you wish, software is at the core of all these technologies. So to me, the smartness is the ability to use software in a very creative, innovative way to unleash new value for the consumer, a new experience.
Danny, AI has been mentioned. I think you might have something to say about it.
I'm familiar with those letters. Yeah, so we see, the whole pipeline of developing from designing to engineering to manufacturing to retail even being part of this whole smart car revolution. And artificial intelligence and specifically generative AI is playing a major role in transforming how automakers handle each of those individual workflows. And so I think that's what's really quite exciting. So it's not just about computing in the car, something we play in and are very involved with many automakers all over the world and made many announcements today on that front. But it's the hardware plus software that is every single department within the automaker has also gone through this whole new wave of intelligence and using generative AI to create better, more efficient designs or more efficient manufacturing processes, as well as safer cars. So we kind of really look at it holistically across every single department within an automaker.
Okay. Remco, from your perspective at here.
Yeah, I think smart for us also means being informed. And here, of course, creates digital map content. And this is a really nice way of efficiently encoding all kinds of information that is relevant for all vehicles. It's helping every individual vehicle to be as smart as possible on the road, being informed with what is relevant for them. But also, and I think that's also very important, actually share that information then amongst all other vehicles and really benefit from collective knowledge amongst vehicles. And as a consequence, the entire system becomes smarter.
Okay. And Rob?
Yeah, the way we like to think about it at Amazon is really working backwards from our customers' problems. And we really think about it from a consumer experience perspective. And what does that mean for the consumer of the vehicle? So we think about the in-cabin experience. So how do we think about making that more intelligent with respect to the IVI systems or even the safety systems inside that vehicle? And then we take it really one step further, and then how do we help our OEMs, how do we help the suppliers in the industry build more intelligent and smarter services for those vehicles throughout the entire supply chain and value chain for the vehicle? And we really think here is it's really about data. I agree with the other panelists around Gen AI really being core to this, and really core to some of the more smart technology is data, and how is the data that's being collected by the vehicle and how we're using that data across the entire supply chain. So we've worked with customers like BMW, Toyota to collect that data, build data hubs, and then use that data across the entire supply chain. So we, again, think about it from the vehicle in-cabin experience, but also now how do you use the intelligence of that vehicle to help the entire value chain?
Rob, one thing I really like about that answer is you say specifically what is being made more intelligent. And that's a question I often have when people speak with hand-wavingly about making something more intelligent. What is being made smarter in automotive in general? Where is this intelligence being added, and what is it replacing or augmenting? And what knock-on effects is it having as far as, for example, purchasing strategies? Maite, I might ask you to speak on that.
Well, so many things are becoming smarter. So if you look at the vehicle itself, we have the architecture of the vehicle being transformed. So before, every vehicle functionality will have its electronic control unit, so its own ECU. And now we are migrating to consolidating hardware. So you have virtual ECUs running very powerful SoCs, capable of running machine learning and AI at the edge, and also powering several displays with high resolution. When you think about consolidation, you also have to think about how the sensors in the vehicle are communicating with these virtual ECUs and the domains and zones. So we also are migrating to modern in-vehicle networking solutions that enable safe, fast communication with high bandwidth, with cybersecurity in mind, of course. In terms of software, we are migrating for this monolithic approach that the software is highly dependent on hardware to hardware abstraction and slicing the software into chunks. So if you have smaller pieces of software, so microservices and functions, you are capable of making changes and updates in these smaller parts instead of having to update the full software platform. And last but not least, the cloud. So instead of just using the clouds to provide connected services on top of what is available in the car, now we are talking about cloud-first approaches. So development environments being made in the cloud, available so to provide collaboration between players. You also have development that is not really dependent on the hardware. So it's a full transformation. We're talking about the digitalization of the whole vehicle life cycle.
Yeah, we see this challenge that we're doing with the smart cards. Really, there's two computers. There's the one in the car, but there's the one in the cloud. And they are both dependent. And there's definitely an advantage to having the same architecture, if you can, between the two. There's this constant training and deployment, but collection of data and transmission back. So I think one of the things that really is smarter is the development process. It's never going to end. The software for your car will never be complete. Just like your phone, right? Your expectation is you're going to get these updates. Your car, first of all, I don't know why you'd buy a car today that couldn't get updates, just like you wouldn't buy a phone that was fixed. So I think we're going to evolve to that point, and the development process of collecting data, iterating on that software, being able to simulate and test that software for safety before it even goes in the car, that whole process is key and is getting a lot smarter too.
Absolutely. Maria, from Elektrobit's perspective.
So I absolutely agree. So the what? So all of this smartness is across every aspect that we have in a software-defined vehicle. And to build on what Danny said, it's also how we are doing things, where a lot of the smartness is coming. So the ability to approach the vehicle like Tesla did is from a system that can be updatable, and it's a living thing over a period of time. It's a new approach that makes a vehicle smart. If you take Sonia's approach, like in the last few years, to connect entertainment and in-vehicle software to create a totally different emotional experience and the connectiveness. This is also a very different smart approach of how to include adjacent industry. So we are looking into the technology and all of the aspects of the mobility ecosystem itself, as well as how we are developing these technologies.
Okay. Remco, from his perspective on this.
Yeah, I think a lot has already been said, but I think what is really also interesting is to look at why you would add smartness, right, along these two sides of the story, of the coin. On one hand in the vehicle, on the other hand in the cloud. And I think in the vehicle, of course, you're trying to please the end user experience, right, make an ever more personalized end user experience. Understanding the user's intent, understanding how they behave in the vehicle to then adjust to that continuously and create more relevant services for that user in time, in place. I think that's really critical to add smartness. It's also to support the vehicle in its decision-making, advanced driver assistance systems, autonomous driving functions. That's where you need to add a lot of smartness. And I think in the overall development, it's trying to be optimized to deliver as effectively as possible what the user needs and what the vehicle needs at any given moment in time. So I think, smartness, I fully agree with the rest of the panelists, both in the cloud, in, let's say, the product development side of things, as well as in the vehicle to enhance that user experience and the machine capability.
Excellent. So we've touched a bit on the what and the why. I'm interested in looking a little bit at the how now. And as far as we look at the future of added intelligence, is the trend towards more vertical integration or towards collaboration? So will OEMs be doing more buying or more making? And what will drive that? What differentiation will be a major factor in this? Rob, we start with you.
Yeah, I think the answer here is really it's going to be both. And what we're seeing is this is really a good question for the OEMs as well. And where do they want to differentiate with their vehicle offerings and in their in-cabin experience and their entire value chain. So we really think about it from an OEM perspective and where the OEMs differentiate. We're also thinking about from a supplier perspective where they want to differentiate as well. And so what we're really seeing is an opening up of smart vehicle technology with regard to things like software-defined vehicles. And with SDV and software-defined vehicles, what we're really seeing, is that we're creating, common and open interfaces like SOFI, et cetera, within the vehicle that allow different suppliers to interact differently than they have before, right? The idea of having just a closed box system, where it was one component, didn't really interact with other components inside the vehicle. I think those days, right, are that's what we see changing. We see that really opening up. So I think what we'll see is OEMs will think about the areas they really want to differentiate. We're going to see suppliers think about areas where they really want to differentiate, and we're going to see this, blending across different domains. Like, for example, within an autonomous system or an ADAS system in a vehicle, you have to be connected to the braking system. You have to be connected to the other major components inside the vehicle. So we really do see the answer here is both, and we're really seeing the advent of software-defined vehicles and really open architectures really changing the paradigm here.
Okay. Maria, from your perspective at Elektrobit?
Absolutely. So I don't even see the vertical that strong any longer because the boundaries are blurring. So we're coming from hundreds of ECUs that are not even given any longer like this. And then we went to the domains of these classical infotainment and chassis and powertrain, etc. But if you look now in the motion control, which is a blending between chassis and ADAS, we're talking about HPCs where you have the infotainment and the ADAS coming together. To your point, things are blending together. Whether it will be one brain or three HPCs, we don't know. But we don't have these verticals so strictly separated. I think we need to think more into layers of separating the hardware from the software, separating the layer of the platform from the applications running on this, to enable, to Danny's point on this experience in the connectivity of the smartphone, that we have independent life cycles and have the industry parallelize development and integrate consistently through architecture. So it's more layering and collaborating across the ecosystem than a strict vertical dependencies.
Danny, is that your experience as well?
Yeah, I mean, I don't know, is it horizontal, is it vertical? It's both, right?
Yeah.
I think the key thing is the collaboration, right? And so if you think about, like, in the vehicle, you have a chip, you have a module, you have the software, you have the sensors and the apps, right? So that vertical part, it's vertically collaborated, right? So we're jointly working with our automakers at every single level of that. But then there's this collaboration, as I alluded to earlier, like, we're involved in helping with the design of the cars, all the simulation for engineering, the manufacturing. And so there's benefits from having a single data source of that vehicle through all those different silos within that automaker. Used to be, it would be reinvented, the data exported and re-imported by a different group, and they'd be in a different city in Germany or in Japan or something. And so we're helping to really help streamline that workflow. And then it even goes into retail. So having a car configured and being able to simulate the in-vehicle experience that is in a vehicle that doesn't exist yet, but people can actually take it for a virtual test drive because all that software has been developed. The hardware may be not available yet, but that's simulated. And somebody could put it on a VR headset and experience that car of the future, and it would look and feel and behave like the real car. So we're able to really cut across collaboration through every single department.
Remco, do you feel this collaboration in data is something that HERE is involved in as well?
Yeah, I think a lot, right? I think what we try to do is, of course, where possible, sort of agree upon data standards so that stuff becomes more interoperable. It's easier to exchange information that is so critical, not for individual vehicles, but for entire fleets within an OEM and even beyond a single OEM. So yeah, I think interoperability as a theme here, I think is absolutely critical. Also within the vehicle, I think traditional OEMs were also a bit siloed, and now they realize that in order to advance and to accelerate and to basically take advantage of technology in the best possible way, they also need more collaboration internally even. So where I think in the past, famously, we would deliver almost the same content twice or three times, depending on the different functional domain of the vehicle. You see all of that now being consolidated and unified. And as a consequence, being also consistent in all of these domains. So it really can benefit from collaboration and interoperability within that vehicle.
And staying with you for a minute, so what is necessary to sort of drive this process into the next level? What's going to sort of kick everything forward? Is it more advanced connectivity? Is it more cloud usage? Is it more advanced processing? Is it stronger software, more powerful software? And is electrification driving this process, or is it sort of being pulled along parallel to?
I think this is another question where I think we're going to all agree it's all of the above.
Yeah. But it's always all of the above.
But I think it's at least, I think what's really important is continuous learning, right? And out of all of these things, I think what you need to do, and like also the other panel is saying, is be continuously validating and iterating upon what you're developing. You can do that already on the cloud side, right? In validation, simulation, testing, even pre-deployment into your fleets. But then also in your fleets, in different compartmentalizations of your fleet, you can deploy software and basically validate and learn if this is effective or it isn't effective. And let's say the faster and the more effective this feedback loop, the faster we will accelerate and will make that transformation happen. So I think that wasn't in your list, but I think it's actually the most...
No, it's fine.
I think the rate of innovation is mind-blowing, right?
Yes.
You look at what's happened over the last year. And I think the key thing is that flexibility. If you've divined a particular system, if you've built that system with specs, and you don't have the flexibility to expand it, to update it with new algorithms or whatever, if you've basically hard-coded a chip and a software to an algorithm, it could be cutting edge today, but it's not going to be tomorrow. And so you need to be able to realize that there's the amount of research that's going on, the amount of papers that are getting published, the new algorithms, the new models, it's insane. And to be able to keep up with it is tough. I mean, the one thing that is constant is that you need more compute, right? And you just look at historically over the last 50 years of computing, there's never enough. And the software will always continue to increase in complexity and take up all available compute. And so, we have customers that are putting 2, 3, 4 very powerful SoCs in a vehicle, and they're just going to continue to push those limits. There's really a direct link between the amount of compute in the car and how safe that car can be, right? As you have more sensors, higher resolution sensors, higher frame rates, all of that just generates more data. And you want to have the diversity and redundancy of different algorithms and different sensor types to ensure that they're going to be safe. And it all just requires more compute.
Okay. Rob?
Yeah, what we're really trying to help our customers do is really shift left the development cycle, really accelerate the software development cycle. And what we're seeing is, with the separation of hardware and software, like the rest of the panelists are saying here, is we want to make sure that we're taking the hardware, the chipsets that are in the vehicle, bring them to the cloud, then really help our customers develop that software in the cloud, right? And really accelerate that software development. So to us, it really comes back to how do we continue to shift left? How do we continue to accelerate the development cycle? It's always going to be very compute dependent. We agree that there's just this need for more compute, but it's really the tool chains and the tool sets that are very important here. And as we think about these tool chains and tool sets to accelerate that development, we see technologies now like generative AI really accelerating this very quickly as well, with things that help us generate code and build new code. Again, continue to really accelerate the software development cycle. And I'll come back to the point that I was making before around data. We do think this data that exists inside the vehicle and how we can harness that data that's in the vehicle, now bring that to the cloud and think about how we start to do analytics on that data. For example, can we take the data that we're generating from the vehicle, take that data and use it to help a service tech, right? So they see certain error codes come from the vehicle. Can we use that to help that service tech now think differently about how they diagnose that vehicle? So we're really thinking, helping our customers think differently, not just in the development cycle, but now how do you bring that data and bring it and change the value chain?
Excellent. Ria, I'd love to know what you think about this.
I think I agree with everything that was said. Absolutely.
Okay, Maite, do you agree as well?
I do, and I think just one thing I really would like to highlight is that while all these elements are really important to bring smart vehicles or software-defined vehicles into production, I think it's important to realize that collaboration and standardization are key. You need to have a high collaboration between OEMs and their suppliers. And you need to remove this heavy lifting of developing non-differentiating layers from the OEMs, so then they can focus on what really delivers value to the final customers. And leave this heavy lifting to these very capable suppliers that we have here in the panels, right? And also the idea of collaboration between OEMs. Today we have a very fragmented environment. I think Renko mentioned that. We need standardized APIs. We need standardized communication standards within the vehicle in itself. So we do have now groups like SOFI, for example, Eclipse SDV, Covisa, that are looking to more standardization, but I think this has to be the focus for OEMs moving forward.
I think that a key thing we're focused on, I think everyone is safety, right? How do you show that these vehicles are safe, that they're going to save lives, they're going to be much better drivers than human drivers? And the way you get there is through data, right? There's one vehicle manufacturer that's been having these smart cars longer than anybody else, and they have an amazing amount of data, and that data they've collected is huge. So I don't see automakers sharing the data. But what I think we can do is share some of the processes, and for testing, share the scenarios we need to test. I think that's what's key, is to be able to understand where are accidents happening, why do accidents happen, and hit the root cause of those and make sure that we don't repeat that. And so we can test and validate using simulation, but then we create basically like a virtual driver's license test that is 1,000,000 times more complex than the test that we all took when we were 16. But these self-driving cars then need to be able to handle every possible conceivable scenario. And I think collaborating at that level means if a car is certified to do something, it will be uniform throughout the industry and not what one car says their autopilot does versus another car's autopilot.
I think once we're talking about things that are across the industry, talking about collaboration, we need to address the tier system, which I think is so unique and so pervasive throughout automotive. Now we're adding a bigger pool to the tier system with adding all these semiconductor firms in, which haven't necessarily traditionally been as incorporated into the automotive value chain as they now need to be. How is digitalization and the advent of sort of software-defined vehicles change the relationships with OEMs and their positioning in the value chain, and what adaptations will the tiers need to make in their products or operations to address this new role? Maria, could I start with you on this?
Sure. Supply chain is very complex and very rich in the mobility system, automotive. And there was a video of Jim Farley of Ford last year that went viral on LinkedIn, and he was saying, I have, it was his baseball cap is, I have hundreds of software companies who deliver to us, and it takes us ages, and those companies are not even talking to each other. So, to Maida's point, standardization, APIs, backward compatibility, and the understanding that we do not just only have a hardware architecture, but also EE architecture and a software architecture that needs to be maintained and groomed across vehicles lines for quite some time will structure a lot of this collaboration. And we need to learn to reuse technology, what is available, and share this among the industry. And in terms of challenges, I think that we will move away from this very stiff, strict tier system towards a graph of being a vendor, where sometimes you're using technology from others, but you'll be also supplying technology to others. So it's like in the high-tech space where it's a graph. It's not a hierarchical system any longer, which enables innovation and brings us a lot of speed. Yeah. And there I see three challenges that we have in the system. The one is the technology, all of these new technologies that are coming, the ability to consume technology, to share technologies, and etc. But we also have the challenge of talent. So if we are able, there are not even so many software developers out there. If we're able to collaborate and reuse technology and smartly build these vehicles, we'll be much faster. And the last thing to your point is the tooling. We have to be much more agile and faster in automotive on-prem and off-prem, and how we're building these systems of mobility, interactions, and updatability to connect everything together.
Remco, can I ask you to chime in?
Maria already covered quite a lot, but I think really one of the points that she's also, I think, trying to drive down, I think what is really changing is basically that we see, in order to keep up with the pace of technological development, but also the market trends, the consumer demand, you need to be able to sort of reuse things that have worked at scale, but then be using these things in such a flexible way that you can still add differentiation, customization, and adaptation on top. Otherwise, everything will look bland and boring, and we will not have the strong brands that we have today that cater to a wide variety of needs of many different consumers. And I think that is what the OEMs need to retain. Full control over their brand equity and the brand experience. A big part of that is going to manifest in the digital experience. And I think what is really critical is that, they can use products, standard products that have proven to scale and are, let's say, share resources across multiple OEMs, right? Benefit from each other's progress, but still add layers of differentiation on top. And I think that's really a thing that's changing. No longer we are simply just delivering against unique requirements of every unique OEM, but now I think they're cherry picking and saying, hey, these things actually really work well. We'd like to benefit from that speed, and bring that innovation to the market faster, but still we want to add something unique where we can differentiate in terms of digital experience or convenience and comfort and safety features, as mentioned as well.
Danny, from your point of view.
Yeah, so I mean, digitalization was one of the buzzwords of last year and continues. But I think what's really pretty unique about how it's applying it is just, it's not just in the car, right? That people are talking about how do we change how we develop software and how do we streamline that process. But it's a lot easier when you're starting with bits as opposed to physical atoms, like making a car, designing the car, building a model, a factory, robots. And so now we've seen this digitalization move throughout every aspect of the automaker's workflows, and being able to design and operate a virtual factory and test it before you actually build it. And so we're seeing the adoption of Omniverse as a way to do that for engineering tests, for the manufacturing tests, and even creating virtual showrooms. So these brick and mortar buildings are now going digital, and it really is changing how everybody does their job within that automaker. But it's those same principles that have gone into building the software-defined vehicle.
Rob, anything to add?
Yeah, as we think about, just to take over Danny's point, we think about this, digitalization across the industry, and go back to how we think about technology like virtual ECUs as an example, and where we see how you take that technology either to the cloud, how do you begin to accelerate that development cycle, and use things like virtual ECUs to help speed up a development cycle and drive that digitization. And again, this applies not just inside the vehicle, but across the entire value chain as well. Across the dealer network, the service network, and what we're also seeing here as well with this digitalization is how do we take the data and use that to change and predict what's going to happen in the manufacturing, on not just supply chain, but also on the shop floor. So do we see defects that are happening, that come out of the vehicle, and can we now make changes to the engineering that occurs for the vehicle, or make those changes to the supply chain, or make those changes to the shop floor, so we avoid recalls, we avoid downtime, on the manufacturing floor, so we're not doing reworks and stuff like that.
So we see the link that designer is creating something, and that information goes directly to the people programming the robots,
exactly.
Right? And so, and laying out the factory then to make sure that the thing swings and it doesn't hit something else. And then the other thing that, you have this design vehicle, it goes all the way to that retail. So it's not the marketing agency for the automaker that's trying to recreate this thing. It's the actual data that was used in manufacturing to then render that out and create the TV commercials. So again, there's this incredible efficiency. So if something changes here, it's going to end up correct at the end product as well.
I think there's some more to talk about how intelligence is affecting not just the car, but the entire process of creating a car. But I want to circle back to one thing we sort of touched on, is how the tier system is changing. And there's a lot of talk recently about sort of the emerging tier 1s and tier 1.5s. Maita, what do you expect the role of tier suppliers to be in the future?
Well, I think what we can take from all that we're discussing is that we are transitioning from these hierarchical systems of tiers, so tier 1s having the direct relationship with the OEMs, and they vertically designing the ECUs and the vehicle systems, towards an ecosystem of several different players, right? And an ecosystem that keeps increasing and increasing. We're seeing more and more players now offering solutions for vehicles as they become smarter. So we will see the OEMs having to have a direct channel of collaboration with all the suppliers that are providing services, hardware, everything for their cars. And you're going to need to have collaboration between the suppliers as well, especially if you think about upcoming regulation, for example. So in Europe, you will have upcoming cybersecurity regulation for the GSR. And the OEM will be liable for any software problems that they have in their cars. So if you have a situation, which Maria was mentioning, with James Foley was saying, I have 150 ECUs in my vehicles and 150 different programming languages in my car that I don't have any flexibility to change. And if you are the OEM and if you're liable for the software, you're really in problems. You're in trouble, right? Yeah. So you need to have this ecosystem of collaboration, which of course we see the cloud and digital twins playing a really relevant role in here.
Absolutely. Remco, how about do you broadly agree with that, or?
Yeah, and I think it touches upon things that we've already mentioned, but yeah, so absolutely. I think the strict hierarchy, I think that's no longer really present in most projects that we're involved in. I think it's indeed a network of collaborating partners that together want to achieve something, together along with that OEM. Yeah, so fully agree. And basically we see the OEMs really cherry picking the best components from that landscape to really take advantage of the speed that all of these suppliers will give them.
So let's talk a little bit more about sort of the intelligence outside of the vehicle itself. Assuming this intelligence is sort of generalized to the whole process of putting a car into the world, how will the OEMs be leveraging connectivity, or leveraging cloud space, leveraging AI and software to improve their processes in general? So shortening development time or optimizing manufacturing and vehicle sales. Maria, could I ask you to start on this one?
You can use for anything in your processes. You can use AI, artificial intelligence, to do requirements management. You can use it for screening your talent profiles when you do hiring. You can gather the data of all your customer data and how you do business. Like every retailer these days is doing the price models simulation. You can do this in automotive space as well. So basically you can do all kinds of digital tooling to optimize the business processes, not just the vehicle itself technology, but anything in the production. And how we build things, the whole process of automation, of virtualization, of simulation, of virtual reality, and connecting the digital tools is very much under transformation and very, very strong development.
Okay. Danny?
Well, no, I think, what everyone is talking about is so great. And I love sitting here because I work with all these companies, right? They all build on my technology.
Yeah, of course.
No, but I think it's so true. It's that we're still just at such early stages of this. Yeah. Every type of computing and things that didn't used to involve computing now can take advantage of AI. And so just this whole reinvention of any equation or any process can be improved. And I think that's just really why it is so exciting. And so whether you're developing the software, you're doing a voice assistant in the car, the retail experience. I think what's so cool is, I don't know if people realize, ChatGPT was this kind of aha moment that everybody had, right? And exposure to it. But that's just with language. That's language in, language out. Generative AI is any data stream in, basically any data stream out. So you could say something and video comes out, or pictures comes out, or 3D models come out. Or you can feed video in and have text come out. So it can automatically close caption what's happening in that video sequence. And so one of the things we're working on, it's really cool, is the front-facing camera can be interpreted, and it can inform the occupants of the car what's going on outside. Right? Just, again, that's generative AI. Video pixels in, words coming out. And we're doing this in healthcare with DNA sequencing and just any kind of data, any kind of patterns, any kind of information, any format. And as you said, programming language, that's another language. So you can ask in English to do something, and it will generate the code whether it's HTML or C or sort of you name it. And so it really is a mind-blowing amount of technology that we still really haven't even scratched the surface of.
Rob, almost all this is going to be happening in the cloud, it seems. From your perspective, AWS, how is this transitioning?
We've been working with our customers for probably a decade or more on AI and machine learning. You know, we've helped some of our customers on the shop floor, you know, as a vehicle comes down the shop floor and thinking about, you know, taking pictures, do visual, you know, simulation of where we potentially see defects going down the shop floor. So the way we view this is, so these different silos have existed inside the OEMs, whether it's in the manufacturing, if it's in engineering, if it's in the vehicle, like we see them, or the dealer and supplier network. What we want to help our customers do is really a couple of things. One is, how do you break down the silos using data, right? So how do we take that data from the vehicle, share it with the shop floor, share it with engineering? But as we make now advances into generative AI, to the points that are being made here, is now how do we think differently about the things we've been using AI for. For example, with ADAS systems, we know we have to take lots of pictures in order to build an ADAS system. We have got to send vehicles out on the road, take pictures of stop signs with snow on them, without snow on them, with it raining, sleet, hail, et cetera. Right? And every time you want to think about a new simulation, you have to send a vehicle out there to go take a picture of these different scenes. What we're using generative AI for now is actually scene generation, like a very simple example, but actually a very complex example that really helps things like autonomous driving and ADAS and safety systems. We're seeing generative AI actually inside the vehicle now as well. You know, automated chat box. You know, use Alexa Assistant inside the vehicle. How do I, you know, do this translation? We're seeing generative AI then across programming languages, like Danny and some of the panelists have said here as well. So for us, we've got a history here of working with our customers in different silos. It's how do we help break down those silos, share this data, use generative AI now to take it to the next step.
Fantastic. Well, it's been an absolutely fantastic discussion. Thank you all for joining me here today. Remco, Maria, Rob, Maite, and Danny, it's been wonderful having you here. And for me, Edward, thank you so much. Enjoy the rest of your show, everyone.
Thanks.